2.3, linear functions and slope-intercept form. All right, let's start with two formulas you're going to need. First of all is the slope equation. M equals y2 minus y1 over x2 minus x1. Now, the 2 and the 1, they don't really do anything. It's not a squared. It's not an exponent. It's just saying it's the second y minus the first y over the second x minus the first x. Okay? So get that down, write that down. And then the slope-intercept form of an equation, y equals mx plus b. So you probably remember both of those formulas, but you're going to need them both on this lesson. Problem number 1, find the slope of the line through each pair of points. So slope is m. So we're finding m. So if you notice, what we are given in this problem is an xy point and then another xy point. We've got two xy points. And so really all we do is fill into the formula. The second y minus the first y. Okay, I underlined it. Over the second x minus the first x. So remember that was a negative. So just do that math right there. Negative 11 minus 11. Okay, that's actually a subtraction. If you think about subtraction is add the opposite, you've got two negatives. Two negative 11s, that's going to make negative 22. On the bottom, negative 11 minus 4. I think of it as two negatives. That's going to make negative 15. If you want to think about add the opposite, it looks a little bit more like negative 15. Reduce your fraction. The only thing we can reduce here is negative divided by negative is positive. So that reduces to 22/15. There's your slope. So problem 3, do the exact same thing. We want to find the slope. So m equals y2 is 15 minus y1 is 18 over x2 is negative 8 minus x1 is negative 16. 15 minus 18 on the top is negative 3. And on the bottom, anytime you have minus minus, if you've got a minus minus situation, you're going to add the opposite like that, plus plus. So we have negative 8 plus 16, and negative 8 plus 16 is positive 8. So there's nothing really to reduce there. You're just left with negative 3/8. If you could reduce your fraction, you would. Next one, write the slope-intercept form of the equation of each line given slope and y-intercept. So here's where we want to use that y equals mx plus b. And so in this problem, this is supposed to be easy because we know slope is m and y-intercept is b. So really all we have to do is plug them into the right spot. Plug the m in here and plug the b in here, and that's your answer. So we would have y equals the m number times x plus the b number. So we have plus negative 5. Plus negative 5 is the same thing as minus 5. Number 7 is the same exact question, right? The slope-intercept form of the equation, but the difference is they don't really give us the m and the b number. We have to figure it out from the picture. So the b number is actually easier to find because b is the y-intercept, right? B is the y-intercept, and that's this point right here. B equals 5 because that's where the line crosses the y-axis. So for the slope, you can do a couple of things. You could use the slope formula again, but in order to do that, you're going to need 2 points. So what you want to do is look really close at this and try to find 2 points that hit the grid lines, all right? So, if you look, a lot of these points don't hit the grid lines, okay, until you get way down here. This is like the only one that hits the grid lines perfectly. And we want that perfection because otherwise we're talking about fractions and decimals and stuff, and we don't want to deal with that. So you could, I suppose you could pick these points if you knew the coordinates, but we want to pick this one because we know the coordinates are positive 2, negative 4. Likewise, the only other real good one is this one that we've already marked up here at the top, because I know the coordinates are 0, 5. So this one was 0, 5, and this one is 2, -4 right here. So if you know those coordinates, you could use the same slope formula. But there's a shortcut. If you don't want to use the slope formula, we know that slope is rise over run. All right, so rise over run works like this. Rise goes either up or down. So what I would do is start on the left, start at the point on the left, and count how many you rise or run. So see how you go down 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going down 9. Now down is the negative direction, so I know that's -9. I'm rising -9. And then I'm going to run 1, 2. And I know that to the right is the positive direction. So what I'm doing is I'm going down 9 and right 2. Down 9 and right 2. That's my slope. Down 9 and right 2. Rise over run. Incidentally, that'd be the same thing you get if you did the formula. If you did your y2 minus y1 over x2 minus x1, you'd get the same thing. That's your slope. So if we have our slope and we have our b, then we should be able to write the equation. We know y equals, the slope is -9/2 times x plus the b number is 5. So number 9, we need to do it again. So we can do it faster this time, I think. We see this point right here at 4. That's the b, that's the y-intercept. And then find some other point. And notice there are several different choices here this time of places that hit the tick marks, but probably the easiest is this close one. It's fairly simple because I can just go down 1 and right 1. So my slope is -1 over 1, or that reduces to -1. We always want to reduce our fractions. So then, my equation is going to be y equals -1x plus 4. A -1x, we don't usually say -1x. We can reduce that and say -x plus 4. So instead of saying -1x plus 4, we just say -x plus 4. Now, number 11, notice it doesn't seem like there are any directions, but that just means it's the same directions, right? The slope-intercept form. Okay, we want slope-intercept form, so what we want is we want to make this look like y equals mx plus b. All right, that means we need to isolate y. Get rid of everything else. Move everything else away from the y. So what we would do here, let's start by subtracting this 2x over. Now that cancels on the left side. On the right side, though, you can't do 5 minus 2. That doesn't say 5 minus 2. It says 5 minus 2x. And those are not like terms. But that's okay because, remember, we want it to look like this anyway. So it's going to be just 5 minus 2x, or it might help if you switched it around and said -2x plus 5. Now don't forget to bring down the 5y equals. We have 5y equals -2x plus 5. We still want to isolate the y because that's what we have here. That's what we want. We want y by itself in order to look like what we've got. So I'm going to divide both sides by 5, or divide everything by 5. And think of it as distributive property if you want to. I'm going to cancel this and get y equals. And then right here, I've got -2/5 because I have to divide that by 5. And then I also have to divide this by 5. 5 divided by 5 is 1, so I've got y equals -2/5 x plus 1. There's your mx plus b form. That's slope-intercept form. Number 13, kind of the same thing. Get your y by itself. Get your y by itself. So I'm going to subtract this x over. I don't have like terms, but that's okay. I don't need like terms. I want it to look like this, -x minus 7. Make sure you put it in that order because that's the order that we want, mx plus b. Next, I want to get rid of that -7, so I'm going to divide by -7. And, as like just like above, this -x comes because that's a negative 1. All right, so keep that in mind as you're dividing. When you divide, this cancels out and gives me y equals. But you've got this right here. You're going to have a fraction. You have negative 1 over negative 7. And that reduces to positive because we know negative over negative is positive. So I've got positive 1/7. And then I've got to divide this. Negative 7 divided by negative 7 is positive 1. So there it is. Y equals 1/7 x plus 1. (15) Sketch the graph of the line. Okay, so there are a couple of different ways to do this. One way to graph is to make a table. And most people don't like making a table, but it's very useful sometimes. And basically, what you need to do is have at least 2 points. When we know this is a line, we know that we need at least 2 points. So if you picked a couple of like easy points, let's say we plugged in 0. Okay, let x equal 0. Then y would equal 3 times 0 plus 1. 3 times 0 is 0, plus the 1 is 1. We've got a point right now of 0, 1. 0, 1 is right there. Then let's do another one. Let's do, the next easiest number to plug in is probably 1. So then y would equal 3 times 1 plus 1. So following your order of operations, 3 times 1 is 3, plus the 1 gives me 4. I've got the point 1, 4. X is 1, y is 4. Looks like that. Now, you could do more points, but you don't really need to because we already know what the line looks like. So we should just use a straight edge or something. Draw it as good as possible. It's kind of hard to do it on the screen. So make it look as nice as possible. That's your line, y equals 3x plus 1. Now, if you don't want to do a table, there is a significant shortcut because we know about mx plus b. So think about this. The b number is 1, and that's your y-intercept. So we could have just started there. We know that's 1. We don't need to do a table because we know that's 1. And then this is your slope, 3. And so if the slope is 3, you probably want to think about it as a fraction, rise over run. So almost like unreducing it. Unreduce that to 3 over 1 and think about it as rise over run. I'm going positive 3 and positive 1, which means go up 1, 2, 3 and right 1. Up 3, right 1 puts me right there. So I've got those same 2 dots without needing to do a table. Now, before we move on, I noticed number 16. Number 16 doesn't seem to have a b number, so it wouldn't hurt to put a plus 0 here. At least you need to think about that. Okay, so 17. Let's do 17 without a table. In order to do that, you would need to notice that the m number is 1. So think about your m number as a fraction, 1 over 1. Really, you could do any fraction that reduces to 1. 2 over 2, 4 over 4, any of those would work. And your b number is 3. Okay? So what is b? B is the y-intercept. What does that mean? That means that's where the line crosses the y-axis. So go to the y-axis to 3. Then with your slope, give that line a slope of 1 over 1. Remember, 1 is positive. So up 1 and right 1. And we'd have a dot there. And, you really only need 2 dots, but you can do as many as you want. If you keep going up 1, right 1, up 1, right 1, or reverse the pattern, down and left, down and left, down and left. Sometimes I like to do a lot of points here just to make sure I've got a good line. And so I run that line through. Like so. Now, how many points did I need? I really only need 2. A computer needs 2. I did more just so I could maybe be more accurate. Number 19, same thing. Okay, I want to graph this, but notice it's not in slope-intercept form. So there's a couple of different ways to handle this. You could make a table. And so let's do that real quick. I'll show you how that works. If I made a table, here's what I would do. Easiest thing to plug in is 0. Most people understand that. So if you plug in 0, you're going to have 2 times 0 plus 5y. Hang on. Equals 5. And so the 2 times 0 is going to be 0. So that pretty much just falls out. And so you're left with 5y equals 5. And then, of course, you divide by this 5 to get y by itself. And you get y equals 1. So I'm looking at the point 0, 1. 0, 1 is right there. Now, the next easiest thing to do is not actually plug in 1. Well, I guess you could. You can plug in 1 if you want. Let's do that. Let's plug in 1. So 2 times 1 plus 5y equals 5. So 2 times 1 is 2. You got plus 5y equals 5. We need to isolate the y is what we need because we want y. So I'm going to subtract 2, and I get 5y equals 3. And I divide by 5, and I get y equals 3/5. Now 3/5 is 0.6. So it might actually help you to think of that as a decimal. We have the point 1, 0.6, which is like right there. Now that's actually not the easiest way to do the problem. Okay, but it'll get us there. We could definitely graph that. You connect the dots, draw a line through, that's it. I think what they wanted you to do, though, was use slope-intercept form. And so you might find it easier to do slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. So let's take that equation and let's iso the y. So we'd subtract the 2x, and I'm looking at 5y. Where do I have enough room here? Just go over here. 5y equals negative 2x plus 5. And then I would need to divide by the 5. And that cancels, gives me y equals, and then notice there's going to be a fraction here, negative 2/5 x. And then 5 divided by 5 is 1, so plus 1. So if you look at it this way, you've got a nice equation that you can graph. So you look at your plus 1 is your y-intercept. Well, we already had that point, right? But then you can get any number of other points if you use that slope. Negative 2/5 means we're going to go down 2 and right 1, 2, 3, 4, 5. So right there. All right, here we are at this point. We're going to go down 2 and right 5, and we've got that. Now notice if we connect the dots, I also hit that weird fractional point, and that's fine. But this was nice because I didn't have to work with the fractions. So you might like this way better. Draw as good a line as you could through there, and there you have it.